Okay, this recording is on the last part of atomic structure, which deals with ionization energy. So we are going to look at these things: definition, trends in the periodic table, then how to interpret the graph of successive IEs. So first we look at definition. Okay, I want you to be very clear about the definition. Okay, so for ionization energy, we are always talking about the atom. Okay, so even for chlorine, we know that chlorine exists as molecules, Cl2. Okay, but first IE is always removing an electron from the atom, not from the molecule. Okay, secondly, everything is in the gaseous state. Okay, so the atom, the ion, they are all gaseous. So there's no such thing as solid, liquid, aqueous, or whatever. Okay, second IE is when you remove the next electron. Okay, so here you are removing electron from the +1 ion. So again, everything in the gaseous state. Okay, now I have a question. How about the energy required for this process? Okay, the answer is the energy required for this process is the sum of first and second IE. Okay, I think you should be able to see that if I add these two equations up, the Cl plus will cancel out one another. Okay, so the net result is conversion of Cl to Cl2 plus. Okay, now we look at trends in the periodic table. Okay, so first you need to understand that in ionization energy, we are removing electron from the outermost shell. Okay, so that means one of these two electrons here. So let's say we are trying to remove the blue electron. Okay, energy is required to remove the electron, okay, because this electron experiences attraction from the nucleus. Okay, remember the nucleus contains protons, so it's positively charged. Okay, so it will exert attraction on the electron. Alright, so the factors that affect ionization energy will be 1. Nuclear charge. So this one I think is obvious. The more protons there are in the nucleus, that means the nucleus will definitely exert a stronger attraction on the electron. So that will tend to increase the ionization energy. The second effect will be the screening or shielding effect. Okay, screening effect simply means the repulsion that this electron that you are trying to remove, the repulsion that this electron experiences from the other electrons. Okay, so this screening effect tends to negate the effect of the nuclear charge. Okay, so if you look at this blue electron that you are trying to remove, take note that the screening effect that it experiences comes mainly from the inner shell electrons. Okay, so this blue electron experiences very little screening effect from this red electron, which is in the same shell as it is. Okay, so in short, screening effect comes mainly from the inner shell electrons. So we just look at the inner shell electrons to judge the screening effect. Okay, so now we look at the trend across a period. So let's say we take period 3 as an example, starting from sodium all the way to argon. So as you go across a period, okay, you should know that the number of protons increases by 1. So that means the nuclear charge increases. Then how about the screening effect? Okay, for this one, you need to know how the electronic configuration of the atom changes. So let's look at the diagram above again. Okay, so let's say sodium atom, you know that it has 1 electron in this valence shell. Then when we come to magnesium, it has 2 electrons. Aluminium will have 3, silicon will have 4, and so on. Okay, so can you see that the additional electron enters the outermost shell as you go across a period? Okay, but the number of inner shell electrons remains constant at 10. Okay, and remember, screening effect comes mainly from the inner shell electrons. So across a period, the screening effect is relatively constant. Okay, so to summarize, nuclear charge increases, but screening effect remains constant, and therefore, okay, the net result of these two factors, known as effective nuclear charge, increases. Okay, and therefore, first IE increases across a period. Okay, then you also need to know the trend for downward group. The first IE decreases, okay, because as you go down the group, the number of electron shells increases. That will tend to increase the shielding effect or the screening effect. Okay, you can refer to your lecture notes for more details. So now we look at question 9 to illustrate some of these things. Okay, question 9, you are asked, why is the first IE of neon higher than that of fluorine? Okay, so first you should check the periodic table, okay, to see where neon and fluorine are located, and you'll find that both are located in the same period, and you should also notice that neon comes after fluorine, which means to say that neon will have a higher nuclear charge than fluorine because it has 1 more proton. Okay, so neon has 10 protons, whereas fluorine has only 9. Then how does the screening effect change? It's relatively constant for both atoms because they are in the same period. So they have the same number of inner shell electrons. Okay, so to answer this question, the increase in ionization energy is due to the greater nuclear charge.